Classical physics has successfully been able to explain many phenomena of nature such as appearance of the stars, motion of the planets around the sun, the waves in the string, the ripples in the pond, and so on. Classical physics deals mainly with macroscopic phenomena and includes subjects like mechanics, electrodynamics, optics, and thermodynamics. By using the mathematical equations and laws of classical mechanics, we can accurately predict the behavior of particles on large scale. But classical physics fails to explain the behavior of particles on extremely small scale. We cannot accurately predict the position, velocity, and momentum of subatomic particles such as electron as we are done in large scale using the same laws of classical mechanics. To explain the behavior of particles at extremely small scale, a branch of physics was developed known as quantum physics. Quantum physics is the study of matter and energy at the most fundamental level. It studies the behavior of particles such as atoms, electrons, photons, and so on. Quantum mechanics provides a description of the physical properties of extremely small scale. To understand the term quantum physics better, we should understand the term quantum. So, what is quantum? A quantum is the smallest discrete unit of a phenomena. For example, the quantum of light is photon and the quantum of electricity is an electron. The study of these quanta is known as quantum physics. To understand how quantum physics got its origin, we need to go more than 100 years back in time. The event that gave birth to quantum physics was in 1900 when a group of bulb manufacturers approached Max Planck. They wanted to make their bulbs more efficient. This required a better understanding of the famous black-body curve. Planck was confused how to solve this problem. After a lot of brainstorming, he came up with an assumption that energy in the form of light can only be emitted in discrete amount. It cannot be emitted continuously. 5 years later, in 1905, Albert Einstein used this concept to explain the photoelectric effect, which was the second blow to classical mechanics. According to him, the light consists of discrete particles known as photons. By using this concept, the photoelectric effect was successfully explained and the particle nature of light was established. Later in 1913, Niels Bohr gave his theory regarding the discontinuous spectral lines of hydrogen. He proposed a theory for the hydrogen atom, assuming that the electrons move around the nucleus only in fixed orbits, and when the electrons jump from one orbit to another, they emit discrete amount of energy corresponding to certain wavelength. Later in 1923, the concept of wave-particle duality was introduced by French physicist Louis de Broglie, which assumed that the subatomic particles like electron can behave as both particle and wave. Erwin Schrödinger in 1926 developed wave equation, which gives the probability of finding a particle at any point in space and time. German physicist Werner Heisenberg in 1927 proposed Heisenberg uncertainty principle, which stated that it is impossible to measure the exact position and momentum of quantum particles simultaneously. Other physicists such as Paul Dirac, Max Born, Wolfgang Pauli, Pascal Jordan, and Richard Feynman are the most influential figures in the development of quantum mechanics. Quantum physics is weird and very non-intuitive, yet it has significant contributions in today's technology. The whole computer world is based on principles of quantum physics. Devices such as biological compass, transistors, lasers, GPS, fluorescent light, etc. works depending on the phenomena of quantum physics. In a nutshell, quantum theory is the most profound and established theory to explain the fundamental phenomena of nature. We have been able to uncover the mysteries of nature, and human civilization has been able to come up to here by the understanding of quantum physics. Thank you so much for watching. I hope you find this video informative. If you want more such videos on theoretical physics and mathematics, make sure you subscribe the channel and hit the bell icon.